Okay guys, hope you are understanding my explanation. Okay, now let's get into problem 3. This problem is also related to synthesis by function generation using inversion method, but in problem 2 we have taken 4 bar link mechanism, but here we are taking slider crank mechanism. Let's go through the problem first. Design a slider crank mechanism to coordinate 3 positions of input and of slider for the following data by inversion method. See, these angles 30 degrees and 60 degrees are given for input link, and this lengths 40 mm and 96 mm and eccentricity of 20 mm are for the position related to the slider. Let's go through the solution. Draw two parallel lines L1 and L2 at a distance of 20 mm apart. Take an arbitrary point A on the line L1 for the fixed point for the fixed pivot. I mean for the fixed point, and 3 points C1, C2 and C3 on the line L2 at a distance of 40 and 96 apart for the initial and subsequent positions of slider. Next, rotate the point C2 about A through an angle 30 degrees in the counterclockwise direction to obtain C2 dash, and by an angle of 60 degrees about A to obtain the point C3 dash. Now on joining C1 C2 dash and C1 C3 dash and drawing their mid-normals, we get the point B, and the mechanism is ABC1. Let's go through different steps with the help of these drawings. See, we have to draw two parallel lines. L1 is one of the parallel line and L2 is another parallel line. As the eccentricity is 20 mm, we need to see to it that the distance between these two lines is 20 mm. Okay. Now we need to mark 3 points C1, C2 and C3 on L1 such that the distance C1 C2 is 40 mm and C1 C3 is 96 mm. Next step is we need to join the points AC2 and AC3 by two lines. Next, we need to rotate the link AC2 about A through an angle of 30 degrees in counterclockwise direction to obtain the point C2 dash. Similarly, we need to rotate this line AC3 about the point A in counterclockwise direction to obtain the point C3 dash, and this angle is 60 degrees. So now we have obtained the points C2 dash and C3 dash. Our next step would be to join C1 C2 dash and C1 C3 dash by a line. Next step is we need to draw mid-normals of the line C1 C2 dash and C1 C3 dash. See, you can see here these dashed lines. These dashed lines represent the mid-normals and they are intersecting at the point B. So we have obtained the mechanism, that is A, B1 and A, B and C1 is the required mechanism of Schrader crank mechanism obtained using synthesis by function generation with the help of inversion method.